Hello everyone, I welcome you all in this course on Engineering Drawing 1. Today we will discuss sectional views. Okay, in the contents we will discuss it what it include sectioning, full sections, the cutting plane line patterns, interpreting cutting planes and sections, find the errors in section views, cross-hatching. One more thing I want to tell you here. If you missed the previous lecture, the lecture number is 2. You can watch it. This link is given on and you can go and watch there. If you missed this lecture, it's gonna difficult to understand. Please try to watch this previous lecture so then easily you can understand this lecture. I have explained basics idea about the section views. Go and watch, get the idea. It's easily to understand this lecture if you missed the previous one. Let's move on. Sectioning. To produce a sectional view, a cutting plane in image cutting through the part as shown in figure A. You can see it. Picture the two half of the object pulled apart, exposing the interior construction as shown in figure B. As you can see it here. In this case, we will look toward the left half of the object in the section views. These sectional views replace the right side views. You can see there is a one object. We cut it into two pieces and the direction of the side is this side. And you can see the arrow right side. Full sections. What is full section? The section produced by cutting through the line entire object is called full section as shown in figure C below. You can see the right side views in full section here is given. Also there is this hatching in 45 degree. I will explain in the coming slide. The cutting plane. The cutting plane line is shown as a special pattern. The arrow at the end of the cutting plane line indicate the direction of side for the section views. This arrow. We can think the cutting plane line as showing the edge view of the cutting plane. When a cutting plane line coincides with a center line, the cutting plane line takes precedence. Cutting plane line pattern. What is the pattern cutting line? Okay, figure below show two line pattern used to show cutting plane line. Arrowhead indicate the direction in which the cut object in views. You can see this one is a cutting plane line pattern. There is a length 6 millimeter. This one, if we saw the figure A, the 6 millimeter approximate and the gap is 1.5 millimeter. In figure B, the gap is the same 1.5 millimeter and the solid line is 3 millimeter approximate. If we use this these two line, this is the two line pattern, and if you want to use the B one, B is, should be 20 to 40 millimeter approximate. Interpreting cutting planes and sections. Let's see one by one. Sectional views often replace standard views as figure shown. The cutting plane is a frontal plane and appears as a line in the top views. The arrow at the end of cutting plane line point in the direction of side for front section. The result is called a front section or front view in section, since it replaces the front view in the drawing. Let's move on to continue. As shown in figures, the cutting plane in a horizontal plane appears as a line in the front view. The arrow points toward the lower half in the plane direction of side as for a top view. You can see according to the if we take the reference front point, that is the horizontal cut it, and we are looking to the downside. That is the top view in sections, that is the section views, and this is the hatching in 45-degree. This result is top view in section. Let's continue. Figure below show two cutting plane, one a frontal plane, the other a profile plane, and both appear on edge on the top view. Each section is completely independent of the other and drawn as if the other were not present. You can see it, that object is symmetrical is given here. Okay, that is the front view and the top view, and this one is the side view. The sectioning front and the right side view in section. The front, okay, the front is this side, the right side is this one. We have to look, the arrow is showing here, this arrow, you can see it. We have to look in this side, right side, according to the figure, according to the figure front views, and remaining this one, that one is in this direction. This object is symmetrical, we can cut it into two sides, in this one and a side and bb side. Look, in bb side, these arrow are telling us we have to look to this side and this side. If we are cutting to in this side, that is, let's we consider this one is y-axis, both of them they are y-axis, and let's say this one is a-axis, a side view. When we are cutting, that is the this shape. If we cut into this side, this arrow, look to this arrow, and this arrow is mentioning to the right side. The arrow is here, you can see it, and this a views arrow is telling us we have to look to section view in to this side. The view is given here, the front and the right side views in sections. That is the sections AA, this side the section AA, and the section B is this one. The symmetrical view is a very nice example. Okay, let's continue. Keep the following thing in mind when drawing sectional views. Visible edge and counter behind the cutting plane should be shown as below in figure A. You can see it here. Hidden line should be omitted in section views unless they are necessary, as in figure B. You can see it. A section lined area is always completely bounded by a visible outline, never by a hidden line. The cross hatching in all hatched area must be parallel in a sectional view of a single object along or in assembly. Okay, here is hand on in figure 1. Find the errors in section view. we made the sections, we made the view. Here we want to check where is the error, where is the mistakes. Please, that is the previous that is the previous object. When we cut it, that is the hatching line. It should be in proper. These uh, this line, this cutting head line is showing there is a hole. So we have to tell them there is a hole. That is the we call in engineering drawing language, they called is graphical language. It's mean its graphical language is understanding between one to others guys automatically if is it written in the proper way according to the rules regulations. And also here is it, this one is showing there is a hole. And as well, where we cut it into two pieces. In previous slide there is one object. When we cut it, look, we cut it here, here, in here there is a solid, here is a solid, okay, up to here, okay, there is a solid. And the same thing here is this one is whole, and also this one is holes, also this one is whole. Though where is whole, it's already whole, we don't need to cut it. So when we are making the sketch, we don't need to make hatching lines. So be careful, where is the hole, we have to mention them, here is a hole. And where you cut the object, so you can mention them with the hatching at 20 no, excuse me, 45 degree hatching line. So please do not do the mistake. Here is this guys, this one is the lines he has removed, we have to mention them, there is a hole. And also he is missed here, that is the wrong. uh, don't do this one, okay. And also the D1 is also wrong, don't do this one. And here this guy, he used some extra lines here. Also he is telling us there is a hole, but we don't need it. That is the wrong way he solved it. And also this one here is he missed, and so we don't need it, this one as well. So look it as well, there is also mistake in this graph. Only the correct one is this one. So be careful, do not do mistake in your drawing. Let's move on. Cross hatching. Cross hatching pattern shown in below figure are used to present general material. You can see it here. The correct one is this one, and that is the not correct one. This is the correct at 45 degree. There is a mentions in, okay, that is the wrong one. Do not do this one, do not do mistake. Look, here is a hatching lines, not the proper, this is not 45 degree. And also this one, he have did the mistake. Make hatching line at 45 degree with horizontal, please. 45 degree with horizontal. Only the A part is, A side is correct, B and C are incorrect, they are wrong unless they look better at a different angle. In figure above, correct hatching at 45 degree with horizontal would be nearly parallel or nearly perpendicular to a prominent feature. In this case, the hatching appears better drawn at 30° or 60° or some other angles. Thank you so much for listening this video. So that's all for the today. If you missed the previous lecture, please you can watch it. I have uploaded it already, the lecture 1 and the lecture 2 and the lecture 3. Today we discuss the sectional views. If you haven't watched this second lecture, I have discussed all these basics idea engineering drawing and sketching in lecture 2. All the basics ideas, views, and everything is you can learn in the previous lecture 2. Please, if you miss it, watch the lecture 2, then you can easily understand what we have discussed. Thank you so much. That's all for today. Bye bye.